Hello everyone, welcome to my channel. You're watching Learn Tech with Sandeep Das, and in this session today we're going to cover the day 5, that is testing and debugging with GoLang, and we'll cover unit testing with the testing package, then benchmarking and profiling with Go applications, then debugging techniques and tools, and finally we'll cover best practices for error handling in DevOps scenarios. Now before going further, if you're new to this channel, please do like this video and subscribe the channel. Now that you've done that, let's move to the first lesson. In this lesson, we're going to learn about the unit testing. Now, you might ask me, what exactly is unit testing? Now, unit testing is a practice of testing the smallest part of the application in isolation to ensure that they function correctly. And the word unit, the unit is the context, typically the smallest testable part of the application, like a function, method, procedure, or module, or it could be an object as well. Now, what exactly do we mean by unit testing in Go? So, unit testing in Go perform using the testing package, which provide the support for automatic testing for Go packages. Now, let's learn how to create a very basic unit test in Go. Okay. Now, for this test, we will first have to create a file, that is main Go application file. Okay. There could be multiple function and all that. Name the package. Of course, it should be your package that you are writing. Then create the test file. The test file that you create has to have at the end _test.go. That has to be there. Okay. And the function that you write for the testing purposes, okay, there has to start with the word test. You can see here it's starting with the test and then any other function name, and the pointer you have to the input parameter you have to say testing.t. okay, so that you have to supply. And another important is that you have to import, of course, the testing package. As I say, the unit testing will be working with the testing package. Okay, so import testing, that you have to do. This is the minimum requirement. And after you've done that, we have to just run go test, and that will run the test. Now let me show you practically in our main coding how it's get done. Then you will understand better. The folder that you should be looking at is in the day 5. Inside that unit_test folder, there in simple_test folder, you will find a file called math.go, and this is a very simple package. Okay, make sure you create the package with math or whatever name, and the test file that you create should be the same package. Then only this case will work. Okay, so in the math.go file, we have first defined the package, the name, that's math, and we had a simple function called add. And what that does, this function add accept parameters a and b, and the return output is that retrieve is integer, and inside that function block it return a plus b, so the sum of a plus b. Okay, and in the test file, now look at the test file very carefully. Okay, this is because the first time you are writing the test case. The file name is math_test.go. okay, so this _test.go, that is the important part, because Go will automatically find that file. Okay, so math_test.go, this underscore is the important part. And the package name here, of course, the same name what you are going to test. So math package, whatever name you're giving, just that name. And this is the second important part, where you're importing the testing package, because using this package only we'll run our testing. Okay, and then in the function, make sure you mention the test t in the, like in proper case, test tst, and then the function name that you're going to testing, that one as an input parameter. Okay, t, then the pointer towards testing.t. This is most important part. Okay, that you have to supply as an input parameter. Okay, then what you're doing in a result, okay, we are just calling the function, say add 1 and 2, so its sum should be 3, and result if not equal 3, then t.error. This is how we're throwing the error. If the test is not succeeding, then you're saying that add 2, like add 1 and 2, it should be 3, but you're not getting 3, that's why it's error. Okay, so that error you're printing, and that's a failure case. If it's success case, then it will say done, all tests a success. Now how can we run this testing? First, go inside the simple_test folder. Okay, I'm already in that folder. I'll just simply run go test. Okay, and if I do that, see it's saying pass, because this test worked perfectly. There is no problem, and it took 0.519 that time. And suppose, I mean, it was supposed to give us the 3, right? But in the main function in the math.go file, instead of sum, it's minus, which is not correct, right? It should return the sum, add, not the minus. In that case, if we run this function, run this test, it's saying fail, test fail. Exactly what is the reason? Because add 1 like 1 and 2 should be 3. It should not be -1. That's why it's fail. It's simply mentioning fail, and exactly what this case got fail, it will mention here. Now let's go back and let's fix the case again. And they're not -b but a plus b. And again, if we run, see, this time it's passing and it's okay. Whatever the time it took, it just showing it. This is how we can write the basic or simple test cases in Go. Now we learn about the basic test cases, right? Now I want to cover a bit extra. I'll say the bonus chapter, okay? A surprise one. So I want to teach you about the mock test. And this is very important because we have to write mock tests many times. So what is a mock test? Mocking is a technique used in unit testing to simulate the behavior of a complex real-world objects like network services or databases. It allows you to isolate the piece of code that you're testing and control the behavior of its dependencies. Okay. Then how exactly we can do mock test in Go? So in Go, there are multiple libraries available for mocking, such as GoMock, Testify, or HTTP mock. Now in our example, we'll use Testify package, though it's popular and very easy to use. And of course, refer to the source code that I'm going to show just now. Okay. Now the mock test you will find in this mock_test folder. Okay, here. And there, first look at the service file. Okay, there you have a package my service. We have an interface, external API. We have a my service struct. Okay, which is API, and it's pointing to the it is the reference to the external API. Okay, then we have function that is new, which just create the instance of a my service, and then we have do something where you practically have your business logic there. Okay, now here, okay, we are doing some very complicating fetch data, so fetching them data. Okay, now in practical scenario, we should not, when doing the unit testing, we should not call actual APIs. Okay, what we should do, we should use a mock. Okay, so for that exact reason, we have service_test.go. This is the requirement, right? The package name has to be the same. We are importing the Testify package. Okay, very important, because using the Testify only, we will also create the mocking. Okay, there you will see that do something. Now again, we are testing the main function, which is what? This do something, right? So service, the test file, we have test, that is requirement, it should start with test and do something, the function name, and as the input parameter, of course, you have to supply testing_t. Now that in this code logic, or in this testing case, okay, we are creating the mock. And where is the mock file? The mock file is _mock folder, and then we have external API mock. Okay, where it done the mocking using this Testify file mock part. Okay, so there we are mocking the external API call. Why? Because we should not call actual API. Instead, we should mock the API call response, and based on that, we are asserting. Okay, so assert expectation you're putting here. Okay, now if we run, of course, you have to be inside the mock test folder. I'm already in that folder. From there, just run go test. Okay, it will not call actual APIs. It just do the mock test, and we have that. Okay, test done within 0.232 second. Okay, and this is pass. If anything issue happen in the coding and all, it's not expected, it will go error, just like the simple test, it will error. Okay, so this is a mock test where you have complicated database calls or API, external API calls. You should be using this kind of mock test. Okay. Now let's learn about the benchmarking and profiling in Go application. Okay. Now you might ask me, Sandeep, what exactly is benchmarking? So benchmarking referred to measuring the performance of certain parts of the code, typically function, to assess their execution time and the resource usage. Okay. Now how you can write benchmarks in Go? First, benchmarks in Go are written similar to test, but they use the testing.b, and I will show the difference between the testing.t and testing.b. Now, and then after the next step is that, of course, you have to put this benchmark function in _test.go files only. Okay. Then benchmarks function name should start with benchmark. Okay. Because if you remember the normal test cases, it was starting with the test. So for benchmark, it will start with the benchmark at the beginning. As you can see in this particular example there, it's starting with the benchmark. Okay. And inside the input parameter, it's testing.b, not testing.t. Okay. And then running the benchmark. So when you run a benchmark, similar to just Go test, but as an additional parameter, you have to specify -b or say dash bench equals, that you have to supply. Then the benchmark, it will run as a benchmark. Okay, now let me show you in practical way. This will become more clear, right? The benchmarking example we'll find, or the source code we'll find in benchmarking underscore profiling folder. There, look at this file called calc. Okay, or this is the calculator program, to be honest. Now package calc. Okay, there we are calculating sum. Okay, we are expecting parameter, input parameter as n integer, and returning the data type is integer as well. Okay, so this is ultimately the sum we are returning. Okay, whatever number you're getting, which is looping through and returning the sum value that you're doing. And then of course, now you know you have to have a file that is underscore.test.go. So calc underscore test.go file. There, of course, you're using the package of course, I mean the package name is calc, right? Then we are importing the testing package. That is requirement. Now look at the very crucial thing. Okay, of course, the first, the name, the function name starting with benchmark, then the function name that you are going to test as an input parameter. This is the second important, that's the third important thing. Okay, second, like first one is the package name has to be same. Second one is the importing of the testing package. Third one is that the benchmark, the function name has to be benchmark. Fourth one, okay, fourth one is the input parameter, that is b, that is the data type is what, the pointer to testing.b. Okay, now if you let's look at the compared with the normal test cases, if you see simple test, then math test that you have done, there you use the pointer to testing.t. Okay, but while doing the benchmarking, you have to use this particular testing.b. That is the thing that you have to remember. Then you are running the test cases, and then we will have the exact parameters to see the performance and all that. Okay, so how we can run this test case? Let's go back to the slide and see how we can do the testing. We just have to run the go test and then dash bench equals to. Okay, that we just have to do. So let's do it. Now to run the benchmarking, you have to just run the go test, then dash bench equals, then dot. Don't miss the dot. Okay, this is important. Run it and see it's saying, okay, the architecture is Darwin AMD 64 architecture, then package, that is what, the calculator package, and then we have that benchmarking calculator sum, the function, and then what is the time it took for per loop. It can say sparse. Okay, and okay, and you can see finally it took 1.316 seconds. So this is how we can benchmark any particular piece of code or piece of function and all that using the benchmarking. Now let's learn about profiling. Now what exactly is profiling? Profiling is used to analyze your program's runtime behavior and identify areas that need optimization. Now how we can do profiling in Go? So Go's test package allow you to generate CPU and memory profiles, and you can enable profiling with flags when you run the benchmark or tests. Now how to do the CPU profiling? So run simple this command. Okay, go test, then dash bench equal and the dot, then additional parameter simply supply dash CPU profile is equal to CPU dot prof. Now for memory profile, just similarly go test, then dash bench equals dot, then after that give space, then dash memory profile equal to mem dot prof. Now this CPU dot profile and this mem dot profile are the actual profile data. Now how I can analyze this profile data? Using go, then space tool, then pprof, this particular command pprof, then space actual profile data. If you give that, you can analyze the profile data. Now let me show you in the code, then it will become more clear. Now to generate the profiling data, just run go test, then dash bench equals the dot, and space dash CPU profile is equal to the profile, that the profile file that you want to create. Okay, just run this command to create the CPU profile data. Okay, now let's copy and run this, and see it created this CPU profile data. Okay, now you cannot see it, but we will be able to visualize it a better in different way. Okay, just like how we can create the CPU profile data, we can create the memory profile data also. Okay, for that go test, then dash bench equals dot, then space mem profile is equal to the memory profile file that you want to create. Okay, so just run that. See, it created the memory profile data. Okay, so we have two files which you cannot see directly. I will show you the command to see the data more visually appealing way. Okay, so we have the profiling data. Now how can we visualize the data? First option is using this go tool pprof. This is a very important command. Okay, pprof, then CPU profile. Okay, that's CPU.profile that you created the file. Okay, that is CPU.profile. If you run this, Control C, and you can just paste here, it will just show you the type, the profile data is CPU, the CPU profiling data, time, when you run the profile, that profiling, when you run that data, for the duration of the time the profiling run, and you can see this 84.28. So that is a percentage out of this 1.4 second, that is the sampling uses the CPU. Okay, now this might not be the entire data, you want to see a bit more of it. Okay, how can you do that? You can use, okay, there is multiple ways. I found two way to be very good. Okay, first one using this. Okay, so you can just run go tool pprof then dash http then colon equal 8080. So it will open your browser and you will see a more visually appealing data. Let me quickly show you, and this is the command I run here, go tool pprof dash http then colon issue, that the command that I've shown just here right now, this one. Now if you go to the browser, it will look like this. Cool, isn't it? So it will show all the CPU usage data and runtime also. So you can see all this data over here. Okay, and this is more very visually appealing way. You can see all the flow of the data and everything, runtime and all. Okay, and there is another way using this site called speedscope.app. Okay, in this site you just drag drop or just upload your profile data, that profile, and that you will see more visually appealing way. Here also you can see all the timeline of the data processing happen, all the profiling you can see in a very detailed way. Okay, so one way is this, using that. Okay, while using this particular command, make sure you have installed this. Okay, this particular GraphVish library that is required for running in the browser. These are different ways you can do the profiling, and you can visualize the profiling and do all kind of performance optimization on, or all this performance metric collection you can achieve. Okay, this is a really great way to do this kind of profiling of your application. Now let's learn about the debugging techniques and tool. Now first you have to understand what we mean by debugging. So debugging is the process of identifying, analyzing and fixing bug or any kind of defect in software or normally hardware system, and we have to resolve those issues and fix the problem or fix the bugs and all that. And this is to make sure that our application work well, and there is no software in the world which is bug free, which is like perfect. Nothing called perfect in software. Okay, there will be bugs, there will be problem, there will be issues, and you have to fix it, and this process we call it debugging. Now let's learn about the debugging techniques and tools using Go. First is print debugging, and you can see the simplest form of debugging involve printing values to the console to track the flow of execution or state of the variables. Inside this kind of prints like fmt.println or log.println, at critical point in your code to display values of variables, execution paths or error messages. For example, if you can see here, I'm printing the values to make sure that the variable is set or not, or just print the value of variables to see the variable printing properly or not. This is a form of debugging that you can utilize. Okay. Then unit testing. By now you know what exactly unit testing and how to run unit testing. So writing unit test for specific function or module to ensure they work as expected, and write test cases like using the Go's built-in test package for function with various inputs including edge cases, and run this test to find any big problem or to fix errors. Okay. Then static analysis. So analyzing code for errors, bug and stylistic issues without actually executing it. We can utilize this statistic analytics tools. And there are, what are these tools? We can use tools like GoVet, GoLint, Statistic to catch common mistakes and improve code quality. They can identify issues like unreachable code, unused variable and more. Then interactive debugging. Using an interactive debugger to step through the code, inspect variables, control execution flow. For example, start your Go program with delve, D-E-L-V-E, okay, delve, and set breakpoints and step through the execution line by line. Like you can inspect variables, values, call stack, Go routines, and change variable on the fly to test your things. Okay. Then remote debugging. Now debugging a running application from a different machine, often used for debugging application in production or remote servers. Run your Go application with a debugger, for example, delve with remote debugging support, in server mode and connect it from the dev client on your another machine. And that's how you can do remote debugging. Then profiling. Now profiling we just covered. So just as a review, analyze the runtime performance of your application to identify the bottlenecks, generate CPU, memory and other profile during executions and analyze them with pprof to find the performance issues. And now you know how to check that also, right? Now the next point is race condition detection. Now what is this? This is to identify the race condition in concurrent programs. So run your test or program with dash race flag to detect any race conditions. Okay. Then logging. Now we can record detailed log of program execution for the later analysis with logging libraries like logrus or zap. Implement structure logging at various level. And what is this level? Info, debug and error throughout your application, and analyze logs to understand the behavior of the application over time or in response to any specific event. For example, any issue happens, for example, something unexpected happening, right? Then you should look at the logs to find out the root cause. Okay. The next point is IDE or editor debugging features. Now, what is this? This is about utilizing the debugging feature integrated into your development environment. For example, IDEs like Visual Studio Code, GoLang or Editor with Go plugins can be helpful for debugging your Go application. And use these debugging capabilities of IDE to set breakpoint, step through the code, inspect variable and view the call stack. Okay. Now this is all about the debugging techniques and tools in Go. Now let's learn about the best practices for error handling in DevOps scenarios. Okay. Now, so why we care about error handling in DevOps scenarios? So error handling is a crucial aspect of DevOps where the focus is on the rapid and reliable delivery of software. Effective error handling ensures that when the things go wrong, which of course it will happen, the impact is minimized and recovery is swift. Okay. Now what are these best practices I'm talking about? I have listed this, so we'll go one by one. Okay. First one is standardized error responses. So use a consistent structure for error messages across your application and services. This makes it easier to parse and understand errors, especially when dealing with microservices or complex system. For example, define a standard JSON structure for API error responses, including field like error code, messages, and possibly a detailed description. Okay. Second point is implement robust logging. Detailed logging is essential for diagnostic issues, and log should capture sufficient context to understand what happened and use logging frameworks that support the structured logging. Okay. For example, ELK stack, which consists of Elasticsearch, Logstash, Kibana or Greylog or Splunk. Okay. Now include unique request ID in log to trace the flow of a request through different services, and this is very important for root cause analysis. Okay. The third point is automate error detection. Now use monitoring and alerting tool to detect errors automatically. For example, Prometheus, Grafana, Nagios, Datadog, New Relic, and set up alerts for critical errors and performance metrics. Utilize anomaly detection wherever possible. Then build self-healing system. So design system that can recover the failure automatically. For example, implement auto restart feature, failover mechanisms and dynamic resource allocation to handle spikes in traffic or failures. Okay. Next one is use circuit breakers. So prevent system failure due to overloading or dependency failure. For example, use circuit breakers in microservice architecture to stop cascading failure and give dependent service time to recover. Next one is implement retry mechanism with exponential backoff. Now in case of transient error like network issues, retry mechanism can help resolve the error without manual intervention. Use exponential backoff and jitter to avoid overwhelming the system or the network. This is also important. Then provide actionable error messages. So error reported to user should be clear and actionable without exposing the sensitive system details. For example, instead of giving a message like something goes wrong, provide guidance or more detailed. Like unable to connect to database, please check your database connection settings, right? This kind of messages will be helpful for debugging purposes very well, okay? Then use error tracking and measurement tools. So centralize error tracking to manage and analyze errors across your application. For example, use tools like Sentry, Rollbar, Bugsnag to integrate error tracking with your issue tracking and project management tools. Okay. Then conduct blameless postmortems. Now, after resolving a critical issue, conduct a postmortem to understand what happened, why it happened, and how to prevent in the future as well without blaming anyone. Focus on learning and improving system and processes rather than individual mistakes. Then continuous learning and improvement. So use errors as opportunities to improve both the system and team skills. Regularly review logs, errors, and monitoring data to identify potential improvements. Then the embed error handling in CI/CD pipeline. Now integrate static code analysis, automated test, security scanning in your CI/CD pipeline to catch error more early. Okay, and use these CI/CD tools like Jenkins, GitHub Action, GitLab CI/CD. A lot of options, right? So use them. Then plan for disaster recovery, and this is the final and the most important point. Okay, so have a disaster recovery plan for catastrophic failures. Basically, regularly back up your data, have a secondary site ready, and conduct disaster recovery drills time to time. Okay, so that's it, guys. I hope you learn a lot about testing of Go application on this video. And if you like this video, please do give a like to this video. Comment what you find interesting or what you learn something new today, and please do share this video with others so that this video reach to many other people. Okay, see you soon in my next video. Bye bye.